I want to count the number of digits in a given number. If 1, 2, 3, 4, 5 is given, 5 digits are there. First one is, can be broken down into smaller problems. Is the output dependent on each other? And most importantly, is there a base condition? All three, according to me, can be done using this. How, if you ask me? Look at this, guys. So basically the logic goes like this. I have 1, 2, 3, 4, 5. What did we do? We removed the last digit, incremented the value of count by 1, correct? So what I will do is, here I will say, okay, if I want to count how many digits are there in 1, 2, 3, 4, 5, I will remove the last digit and count how many are there in 1, 2, 3, 4. So the problem becomes smaller, then 1, 2, 3, problem becomes smaller, then 1, 2, problem becomes smaller, then 1, problem becomes smaller, then I reach 0 and I keep returning. So what I will do is, I will remove 5 and I will call again. Or I will call the same function by removing 5 and calling. So you guys know how to remove the digit by dividing by 10 to remove the last digit. But what I will do is, if I am removing 5, that means I have to increment the value of count. So what I will do is, I will call, but when it returns, I have to add 1 to it. So here, I will keep +1 ready because I am removing a digit. And then what I will do is, I will recursively call again by removing the last digit. Now to count 1, 2, 3, 4, I would first like to count how many digits are there in 1, 2, 3. So I should remove 4 and call. Because I am removing 4, I will keep +1 here ready because I have to keep that at the back of my mind. So 1 digit, 2 digit, that's what it means. Then I will again call by removing 4, 1, 2, 3. Again I will remove 3 and call. So before that I will keep +1 ready, just for my reference. Then I will again call by sending 1, 2, removing the last digit. Again I would like to remove 2 and call. So before that I will tell +1. So that I remember I am going to remove 2 and I am going to call. And then again I am going to call, so 1 will be there. I would like to remove 1 and call. So again I will keep +1 ready. And after keeping +1 ready, when I again remove 1 and call, obviously what is going to remain is 0. If 0 means no more digits exist, which means, don't you think this is my base condition? The moment I hit the base condition, what I am going to do is very simple. I will return 0. That is what I will return. When I hit the base condition, see, I will return 0. Whatever is returned, my dear friend, that I will add it to this +1. So I will get 0 plus 1 is 1, like this, which is what I am showing. So 0 plus 1 is 1. That 1 is what I will again return. Hope you are able to think. 1 plus 1 is nothing but 2, correct? 2 digits are there. That I will further return. 2 plus 1 is 3. That I will further return. 3 plus 1 is 4. That I will further return. 4 plus 1 is 5. Hope you are able to think. Ultimately you got 5, which is the number of digits. Don't you think this is recursive solution? So how will the recurrence relationship look like? Very simple. This is what it will look like. If I have a function called as count digits of n, then before counting n digits, I would like to count n minus 1 digits or remove the last digit and count. So see, again call count digits by removing the last digit. How to remove the last digit? N by 10. But because you are removing a last digit, you must keep +1 ready because you have removed it. This is the count. I hope I am clear. So count digits of n by 10 plus 1. This is the recurrence relationship. How many of you understood this with 100% clarity? Put a yes in the chat if you understood it fully. I am not hearing all the yeses, only few are saying. Okay, good, good. So you understood. Now it is just going and writing. The beauty about recursion, it makes your code very elegant. For the programmer, it is very beautiful to write the code. But for the memory, you know what will happen. But that is okay. I don't care about the memory right now. I'll go there and I'll minimize this function and also keep it. Now I'll just tell static void count digits or static int, because it has to return static int count digits of n. In int n it will accept. Inside that base condition we will see, I'll press enter. I'll tell return. Return what? count digits of n by 10. So before I find n, I would like to find it in n by 10. But because I'm removing a digit and sending, I would like to add 1 to this so that I know what is the count, semicolon I will put. I hope I'm clear. Now, but this will be infinite recursion. I would like to end it. So base condition. What is the base condition? If n becomes 0, this is my base. So if in case n is equal to 0, then what should I return? I should return 0. That is what I will return. That's it. Simple. No complications. Very easy. Will this work? Let us go execute and check. So for that, obviously I need to call it. So I'll just tell system.out.println because it is returning something. So system.out.println, and I will tell count digits of 1, 2, 3, 4, 5, 6. So basically 6 it should give me. Let's see if I go back and if I put in the relevant command, compile, no issues, execute, as you can see 6 you have got. So perfectly it works. No problem at all. Am I clear till this point of time? Did you understand? How many of you understood this fully? Everyone understood? Okay, cool. So this is how recursion works. Now there are n number of problems we can keep solving. There are many problems more which we can keep solving. I can keep going on and on and on. Tomorrow also we will be solving a lot of problems, or in the next class, right? So, but today I would like to halt the discussion here, because this is something which I want you to go and wrap your head around, and I would like you to write code for it and try to understand what you're writing, right? So it is very important, guys, that you go and practice. Now go online, try to find some questions on recursion, try to provide your solution, try to write it iteratively also, try to write it recursively also. Because learning is one thing, practicing is a totally different ball game, and what many of you are lacking is the practicing part of it. Anyways, let us continue with many more exciting programs of recursion.